Good morning. Today we are going to see new chapter Metallurgy. Before we deal with the chapter Metallurgy, let us see some basic terms coming in this chapter. The first term is minerals. What are minerals? Minerals are the naturally occurring chemical substance in the earth's crust which are obtained by mining. The next term is ore. The ore is the mineral from which a metal can be easily and profitably extracted. Now the next term coming is gangue. Gangue is the earthly materials or impurities present in an ore. So we can call the impurities present in an ore as gangue, and we know that the main impurity present in any ore is sand or silica, SiO2. Now let's see the definition for metallurgy. Metallurgy is the scientific and technological process used for the isolation of metal from its ore. Now I have written here the principal ores of few elements. The metal aluminium, the ore is bauxite. The composition of bauxite is Al2O3.2H2O. Next metal iron. Iron, 4 ores of iron are written. The first one is hematite, Fe2O3, magnetite, Fe3O4, siderite, FeCO3, and iron pyrites, that is FeS2. So the sulfide ore of iron is iron pyrites with formula FeS2. Now the next metal is copper. The main ores of copper are copper pyrites, CuFeS2. Next is malachite, CuCO3.CuOH twice, cuprite, Cu2O, copper glands, Cu2S. Now next metal is zinc. The sulfide ore of zinc is zinc blende. Now zinc carbonate is calamine and zincite is zinc oxide. So these are the principal ores of certain metals. Now there are 5 metallurgical operations, or we can say the extraction and isolation of metal from its ore involve 5 metallurgical processes. The first is crushing and grinding of the ore. The second operation is concentration of the ore. Third is conversion of concentrated ore into metal oxide. 4 is reduction of metal oxide. And fifth process is refining or purification of metals. So in this chapter we will be dealing with each metallurgical process. So let's discuss the 5 metallurgical processes. First is crushing and grinding of the ore. So once we get the ore of the metal, we crush and powder it. Always the ore is taken in powder form for the further metallurgical process. Now the second metallurgical process is concentration of the ore. So metallurgical process. First is crushing and grinding of ore. Second metallurgical operation is concentration of ore. Now, what do you mean by concentration of ore? Removal of unwanted materials, especially silica, clay, etc. from the ore is known as concentration. So as a result of concentration of the ore, most of the impurities, mainly sand, clay, present in the ore will be removed. Now the concentration is also known as benefaction or ore dressing. So concentration of the ore or benefaction of the ore, or it is also called ore dressing. And this method, concentration method, helps to remove most of the unwanted impurities present in the ore. Now there are different concentration methods used for the concentration of ores, and it depends upon the difference in physical properties of the ore and the impurity. So we will discuss each concentration method. The first concentration method is hydraulic washing. Hydraulic washing. Now, hydraulic washing is based on the difference in gravity of the ore and gangue particle. So, this hydraulic washing is also known as gravity separation. So, hydraulic washing or gravity separation. And the principle involved is the difference in gravity of the ore and the gangue particles. And in this process, an upward stream of running water is used to wash the powdered ore, and the lighter gangue particles are washed away and the heavier ore particles are left behind. Now this method is used for the concentration of oxide ores. Mainly oxide ores are concentrated by hydraulic washing method. Now the second concentration method is magnetic separation. Magnetic separation. Now in this method, this is based on the difference in magnetic properties of the ore and the gangue. If either the ore or the gangue is capable of being attracted by a magnet, then we can use magnetic separation method for the concentration of ore. Now what is done is the powdered ore is carried on a conveyor belt which passes over a magnetic roller, and if the ore is attracted by the magnet, then the magnetic roller will attract the ore and they are obtained, and the gangue particles which are not attracted by the magnetic roller will be obtained separately. Thus we can remove most of the impurities present in the ore with the help of magnetic separation method. An example is magnetite Fe3O4 can be concentrated by this method. Now the next method used in the concentration of ore is froth flotation method. Froth flotation method is mainly used for the concentration of sulfide ores. So for sulfide ores, the concentration method used is froth flotation method. Now the principle of froth flotation method is the ore particles get wetted by oil, whereas the impurities are wetted by water. So that is the principle of froth flotation method. That is, the mineral particles or ore get wetted by oil, while the gangue particles are wetted by water. Now what is done in froth flotation is the suspension of powdered ore is made with water, and to this suspension we add two things. One is collectors and the second is froth stabilizers. So to the suspension of powdered ore in water we add collectors and froth stabilizers. Now a rotating paddle agitates the mixture and draws air in it. As a result, a froth is formed which carries the mineral particles, and the froth is light and is skimmed off, and it is dried for recovery of the ore particles. Now what are collectors and froth stabilizers? What is the role of collectors in froth flotation method? Collectors enhance the non-wettability of mineral particles. That is, it give water repellent property, because we know that the mineral particles get wetted by oil. So, these collectors when added, they give water repellent property on the surface of ore particles. So, the role of collectors is to enhance the non-wettability of the mineral particles. And example for collectors is pine oil. Example is pine oil, xanthates and fatty acids. These are examples for collectors. Now, froth stabilizers. Froth stabilizers helps to stabilize the froth formed, and this froth contain our mineral particles. So, the froth stabilizers commonly used are cresols and aniline. So, example for froth stabilizers is cresol and aniline. These are two examples. Now, again, suppose you want to separate two ore containing two sulfide ores, two mixture of sulfide ores, then we can use depressants in froth flotation method. Depressants. So, what are depressants? Depressants selectively prevent certain type of particle from forming the froth. That means, if you want to separate two sulfide ores, if you add a depressant, depressant will prevent one of the ore to come with the froth. Thus, we can separate two sulfide ores. And an example for depressant is sodium cyanide. And sodium cyanide is used as a depressant to separate lead sulfide and zinc sulfide. So, to this mixture of ores, if you add sodium cyanide depressant, sodium cyanide will prevent zinc sulfide from coming to the froth. So, only the lead sulfide ore will come with the froth. And sodium cyanide, it prevents zinc sulfide from coming with the froth by forming a complex with zinc sulfide. And the complex formula is Na2 Zn Cn 4 times. So, sodium cyanide is an example for a depressant when we have to separate lead sulfide and zinc sulfide ore. Zinc sulfide will not come with the froth, but lead sulfide will come with the froth, as the sodium cyanide will form a complex with zinc sulfide. Now, froth flotation method is over. Now, the next method, that is number 4, is leaching. Next concentration method is leaching. Now, the principle of leaching is the ore is soluble in some suitable solvent while the impurities are insoluble. So, for leaching, we take a suitable solvent in which the ore particles will dissolve, where the impurities will not dissolve. And you have two examples to study under leaching. The first example is leaching of alumina from bauxite. So, we are going to see the first example, that is leaching of alumina from bauxite. Now, we know that the chief ore of aluminium is bauxite, and it contains impurities like SiO2, then iron oxides and titanium oxide. Now, we can remove most of these impurities with the help of leaching. Okay, so leaching of alumina from bauxite. Let's see the different steps involved in leaching of alumina from bauxite. It involves 3 steps, and we know that the principle of leaching is the ore or the mineral is soluble in a suitable solvent, and the solvent used here is sodium hydroxide solution. So, it takes place in 3 steps. The first step is treating the powdered ore with a concentrated solution of sodium hydroxide at 473 to 523 Kelvin and 35 to 36 bar pressure. In this way, aluminium oxide, that is Al2O3, is leached out as sodium aluminate. Also, the impurity present, that is silica, SiO2, will come out as sodium silicate, leaving the other impurities behind. So, I am going to write the equation, that is the reaction of Al2O3 with sodium hydroxide, concentrated solution of sodium hydroxide. We get sodium aluminate, and the formula is 2NaAlOH 4 times. So, this is the first step, dissolving Al2O3 in sodium hydroxide to form sodium aluminate, and the silica present will also dissolve as sodium silicate. Now, the second step is the aluminate in solution is neutralized by passing carbon dioxide gas, and hydrated Al2O3 is precipitated. So, next step is to pass carbon dioxide gas through sodium aluminate. We get hydrated aluminium oxide. So, I am going to write the equation. The equation is 2NaAlOH 4 times plus carbon dioxide gas will give hydrated alumina, that is Al2O3 dot XH2O, plus the byproduct is sodium bicarbonate. Now, at this stage, that is when this reaction takes place, a solution is seeded with freshly prepared samples of hydrated Al2O3, which helps to induce the precipitation of hydrated alumina. Now, the last step is the hydrated alumina is filtered, dried and heated to give back pure alumina. That is, from Al2O3.XH2O, we remove H2O and we get pure alumina, Al2O3, and the sodium silicate remains in the solution. So, the last equation is Al2O3 dot XH2O heated at 1470 Kelvin, we get Al2O3 solid plus XH2O. So, this is leaching of alumina from bauxite, which takes place in 3 steps. Now, there is one more example for leaching, that is hydrometallurgy or leaching of gold or silver. So, next example is leaching of gold. Gold symbol is Ag, or silver symbol is Ag, or gold Au. Leaching of gold or silver, and this method is also called hydrometallurgy. Hydrometallurgy or leaching of gold or silver. Now, the principle is same, that is, the metal is dissolved in a, or the ore containing the metal is dissolved in a suitable solvent. Later, after dissolving in the suitable solvent in hydrometallurgy, we recover the metal by adding a more electropositive metal like zinc. So, the principle of hydrometallurgy or leaching of gold and silver is the metal ore is dissolved in a suitable reagent, followed by displacement of metal by a more electropositive metal. This is known as hydrometallurgy. Now, let us see the hydrometallurgy or leaching of gold and silver. For gold and silver, the solvent used is sodium cyanide or potassium cyanide. So, in leaching, first gold or silver is dissolved in sodium cyanide or potassium cyanide, we get a complex, and later from this complex the silver or gold is extracted by adding a more electropositive metal like zinc. Zinc is usually used to displace gold or silver from the complex. So there are two equations. I'm going to write the equation. Hydrometallurgy, 4M plus 8Cn minus. M can be gold, Au, or silver. Cn minus is from sodium cyanide or potassium cyanide, which is used as the solvent, plus 2H2O plus O2 gives, this metal forms a complex with cyanide. So the formula of the complex is MCN twice minus plus 4OH minus. Now in the second step, the cyanide complex will combine with a more electropositive metal like zinc. So the second equation is 2MCN twice minus plus zinc will give this metal in the metal complex will be replaced by zinc. So Zn Cn 4 times 2 minus plus we get the metal 2M, which can be gold or silver. So this is the reactions taking place during leaching of gold or silver. So with this we finish all the concentration methods. So in total we have 5 concentration methods. The first one is hydraulic washing or gravity separation. Second is magnetic separation. Third is our froth flotation method, and fourth is leaching. And under leaching we have two examples. One is leaching of alumina from bauxite and leaching of gold or silver. So this is the second metallurgical operation. Now let us see the third metallurgical operation. The third metallurgical operation is conversion of concentrated ore to metal oxides. After the concentration methods, the metal ore is converted to metal oxides because metal oxides are easy for reduction. Two methods are used for the conversion of concentrated ore to metal oxide. One is calcination and the second is roasting. So let's see what you mean by calcination and roasting. Now the third metallurgical process is conversion of concentrated ore to metal oxide. Two processes. First is calcination. Now what do you mean by calcination? Calcination involves heating of ore in the absence of air. And during calcination, the moisture present in the ore is expelled out and we get the anhydrous ore. So heating in the absence of air is calcination. An example for calcination is zinc carbonate will decompose on heating in the absence of air to zinc oxide plus carbon dioxide. Now the next method for conversion of concentrated ore to metal oxide is roasting. So the next method is roasting. Now in roasting, and this roasting is mainly used for sulfide ores. Sulfide ores are converted to metal oxides by roasting. In roasting, the ore is heated in a regular supply of air in a furnace at a temperature below the melting point of the metal. So here in roasting, the metal ore is heated in presence of air. An example for roasting is zinc sulfide. I told sulfide ores are usually roasted. Zinc sulfide plus oxygen, we get zinc oxide plus sulfur dioxide. So this is roasting. And usually during roasting and calcination, we add something called flux. Flux. So what is flux? A flux is a substance which when mixed with calcinated or roasted ore chemically combine with the impurities present to form an easily fusible material called slag. Or we can say the flux when added to roasted or calcinated ore, flux will combine with gangue to form slag, which are easily fusible material. So gangue is the impurity, flux is added to remove the impurity as slag. Now there are two types of fluxes. One is basic flux and the second is acidic flux, or acidic flux and basic flux. So what is acidic flux? Acidic flux is added to remove basic impurity and basic fluxes are added to remove acidic impurity. So let us see an example for acidic flux. Acidic flux, example, calcium oxide or lime. This is our basic impurity. That is our gangue. So we add a flux which is acidic in nature, that is silica. So this is our flux, and we know silica is also an impurity, but silica is a acidic impurity, but it is added as a acidic flux. So silica plus calcium oxide, we get the slag calcium silicate. This is our slag, CaSiO3. Now the second type of flux is basic flux. Basic flux. Basic fluxes are added to remove acidic impurity, and acidic impurity is silica. This is our gangue impurity. Plus calcium carbonate is our flux, which is basic in nature. We get again calcium silicate plus carbon dioxide. Calcium silicate is our fusible slag. So flux, two types, acidic flux to remove basic impurity and basic flux to remove acidic impurity. So with this we complete the first three metallurgical process, that is crushing and grinding of the ore, second is concentration of the ore, third is conversion of concentrated ore to metal oxide. Thank you.